So what I was saying was, if you have any comments about some changes that you had to make in the work processes in order to take advantage of the diagnostic data that comes out of field devices. And what we find, and why we started this whole ISA 108 standards effort, is that there's already a ton of smart devices installed out there. The problem is that users don't necessarily put the proper work processes in place to take advantage of that data, right? They're still using a lot of the same maintenance practices that they've used for the past I don't know, 100 years. I mean, have maintenance practices and process plants really changed that much, you know, over the past 50, 60 years or whatever? So what I'd like to ask you guys is, you know, what are some of the things that you did to initiate that culture change in your plant to get your maintenance people and your operators or what have you to actually get access to that data and use that data effectively? Or is this an ongoing challenge? Or, you know, basically anything you have to say about that topic would be good.
Thank you, Larry. Does anybody want to if you wanted to talk about that, just grab a microphone, please.
Can you hear
hold it close to you, so that
you can hear me. Yeah, it's okay.
Yeah, it's good.
No, at Rasgas on the super trains, what we have done is we have integrated all the field devices, including the DVCs and all the works, into the control system, and we integrated that into the alarm management system. We have integrated that to the PI. So to answer your question, what we did is we had the asset management system. So you got a problem with DBC, or you got to issue the temperature transmitter. We were daily collecting data on the MSA bits and generating an alarm management report for every shift, and it goes to the maintenance team straight away. And also we did an email alert for a device fault directly to the maintenance supervisor for that section of the plant. So what he was supposed to do with the alert or the report was to generate a corrective notification. So that's the workflow we followed, and that's been very effective. Rather than waiting for the panel operator, the field operator to go and find out, okay, I got a problem with this, so I need somebody to raise a notification, I need somebody to look into the issue. So we took a proactive approach of getting the data up front, including an email alert, and taking a corrective action straight away. So we move proactively forwards rather than waiting for the operations to come back to maintenance and inform what's going wrong. So it's done because we got several thousands, because we're talking about super LNG trains. It's not peanuts, you know. So we got massive number of field devices all over the plant, only on the super trains. The rest of the trains are still following the conventional way where the panel operator gets an alert, say my level transmitter is faulty. So he informs his supervisor, and that guy then, during our meeting, says, okay, I need somebody to raise a notification and take action. So we move from that approach to a proactive approach of taking action straight away.
Anybody else want to talk about that kind of cultural change? Gabor has something to say about it. Cultural change in terms of addressing maintenance more.
Yeah. So our way was a little bit different. We started more than 10 years ago to deal with EMS and PRM systems. We acted with many plants with day systems, and after that nothing happened. In reality, day systems were very underutilized. 10 years ago, we decided to create a maintenance strategy. We decided to follow the reliability-centered type of maintenance. And it was accepted on a highest level in our group. And after that, we created an action plan, a rollout plan for the integration, because all the EMS and PRM solutions weren't integrated into a big one. It was a tough job for the operational staff or the administration staff to handle them. So that's why we decided to integrate them into a big one. That was the third step. And after that, we cooperated with the unit staff, because the operational staff in the process unit and good cooperation, I think it's nothing, because if the maintenance staff believe in the system and know it's a good way, I think it's 50% of the success. If the unit leaders, the operational staff, from the operator up to the unit manager, support us, okay, guys, you do. I trust on this system. I trust on the predictive maintenance and the proactive maintenance. I think it's close to 100% success. So we involved not the maintenance staff, the outsourced maintenance staff, the contractors, as well the unit leaders, operators, everybody from the unit. And step by step, we try to change the way of thinking, the culture. It was around 10 years journey. So what you can saw before on the slide, it's a result of closely 10 years. Thank you.
John, you have something to add?
Well, yeah, the big payout we see for the diagnostics for instrumentation is averting unplanned shutdowns. I mean, if you can save a process plant from shutting down, that's some a pretty big payout. So we've actually have a select group of operators that we've trained in the use of our instrument asset management system, which they utilize and they have used to avert chaos in the plant. For example, some instruments are capable of plugged impulse line detection. They've been able to, view that diagnostic and take care of that issue before it became before safety valves started lifting and the flare lit up, kind of thing.
Okay. Other questions from the field? I have one I'd like to ask, but all right. So I'll ask one. If nobody's raising their hand right now. This is really for Jeff, although maybe Bill has something to say about it as well. You talked about having 35 plants, and you had developed a lot of additional criteria for your field devices over time, including performance-based ones. But in terms of having 35 plants and a lot of networks and obviously a lot of production equipment all over, can you talk about how you support those many networks in terms of yes, they're all there and you've got these specifications, but how do you support them between, I doubt that you have IT organizations in 35 spots, but can you just tell us a little bit about how you support it?
Sure. How do I support them? And this is going to sound funny, but I have people in the room who can attest to what I'm about to say. We don't have downtime, so support is easy. We literally don't have issues where our field bus goes down for any length of time due to any adverse behavior or any adverse devices or overloading or improper planning. And I know that sounds odd, and I know that there are people in the room going, yeah, right, but that's a fact. I haven't had to deal with a downtime issue myself in over, 2.5, 3 years, and that wasn't due to any misbehaving device. It was due to somebody in the plant making a poor choice. So from a support perspective, though, I have remote support capabilities into almost everything we have everywhere. So I could sit at 2 o'clock in the morning if I had to, and I've done this. I could sit at my house and connect to a camera in Brazil and help a guy set it up if I needed to. So we have a lot of capability to reach out and touch what we've deployed globally.
Okay, thank you. Anybody have questions from the floor again? Because the analyst never runs out of questions. So, nobody, okay, I'm going to ask one more. This is really for Gabor. I guess could you talk about specifically about the way that you integrated with the control valves? The slide that you had was pretty impressive, but were you doing a brownfield to integrate these? Can you just tell us what you did to integrate with the control valves?
On the field, at the field devices, so within the field devices, the most important are the control valves because they have a biggest impact on the productivity. We know the transmitters, pressure, temperature transmitters as well important, but if we have a problem with one of the control valves, sometimes it causes a really big problem in a production. Sometimes outages or it causes slowdowns. So so the biggest impact in the oil and gas sector caused at the field the control valves. We follow two ways. One is for the we made a predictive type of maintenance before the turnarounds because more than 10 years ago, if we have 50 pieces of control valves in the process unit, we removed all of them for supervision. We check the packings, the closing elements, the actuators, everything, because we cannot see inside the control valves. Using the diagnostic solutions, before the turnarounds, we put to the bypass some valves, and the rest on the first day of the turnaround of the plant shutdown. We do the maintenance, and based on this information, we decided to remove or leave in a process unit the control valves. If we have around based on using this method, we can remove on average 10% of the control valves from the process unit, because if we remove a good control valves, it's not very healthy for them. So based on this diagnostic, we can select the bad actors. This is one way for the control valve diagnostic. Another way is a predictive type of diagnostics in an EMS or PRM type of frame system. We run special tools for a online valve diagnostic, and before the unit shut down, we can early recognize or early detect the problems. For example, the stacking problems, travel deviation problems, etc. So this information directly goes to the SAP PM, and in the morning meeting, the unit leaders and the maintenance staff together are able to decide based on the valve and the risk. So based on the criticality, we can handle or postpone or do the maintenance immediately before the unit shut down.
Okay, thank you very much. Any other questions from the floor? I'll take one more. Go ahead. And then we'll have to close this panel. Sorry.
Thanks. Good morning. I'm Paul Adhere. I'm from Cisco. And I had a question for you guys. You all represent customers with reasonably critical infrastructure, things that our society needs and stuff like that. And you've all chosen to deploy one of the different, industrial standards. If you had to stop and think and ask this industry community here in the audience, what one thing should we work on to make your lives easier or safer, or what keeps you up at night, and what can you ask of the standards groups that what we could work on to help you guys? What are just top of your head? What are the big things we need to work on?
Great, that's a good question. Thank you very much. Does anybody want to talk about that? Not everybody has to, but if anybody has something they'd like to say, go right ahead, Chuck.
Yeah, what we would like to see and why we chose ISO 100 was one of the reasons that we want a standard and a product which can integrate with various types of communication wireless protocols rather than buying 100 devices, 100 protocols. We wanted one standard which can integrate all these combinations into a single physically or software-wise or wireless-wise. So, and that was the main driver why we chose ISA 100.
John?
And that's what we prefer to have.
John, go ahead.
Sorry, I didn't mean that. Well, we need everyone to play well together, and we need all the bright people at our suppliers to work together. I guess what we see is that the interests of the end user is in standards, but the standardization is not always in the interest of our suppliers. Our suppliers seem to continuously preempt our efforts toward a users-driven standard with proprietary solutions. And so we end up, we're headed towards the walled garden, like the Apple model, if you will, of we control everything, versus the other, which maybe is a little more chaotic model, which is that there's a lot of freedom to choose. And that's one of the reasons we like Foundation Field Bus, is that it does continue to emphasize that freedom to choose, but the support and the effort on the part of our supplier community is maybe not all that enthusiastic, because it doesn't necessarily translate into them winning jobs, if you will. You know, their support of standards, for whatever reason, doesn't always mean that they beat their competitors, right? But from the standpoint of an end user, I value the polish and the excellence of their standards-based solutions much more than the proprietary ones.
Jeff, can you pass that down to Jeff?
I don't think I can add to what's been said from a process or from a overall perspective. I'll make mine maybe a little more functionality specific, Paul. And something that you've heard me talk about before is one of the needs we have is for forensic diagnostics. I think the diagnostics that people put in products today are great, but the problem is when something goes down or something fails and the power is dropped, you don't know what happened, you don't know what it saw, you don't know what it knew. So at that point in time, you have nothing but a dead piece of hardware that needs to be swapped out, and you have no hope of reconstructing what its failure mode was if it's dead. What I'd like to see is diagnostics be a little bit more proactive from a forensic perspective and keep that information, make that information available somehow after I've pulled that device, when I throw it up on a bench, and I want to determine what happened, what failed, and where it came from. Everyone's diagnostics today are, oh, look, bad things happened, and it just, that information is gone as soon as that device is powered off. That's useless information. And at least from my perspective, we have assembly systems that build axles every 10 seconds. So every 10 seconds, an axle comes off the back of that line. They are not interested in my taking a half an hour to an hour to figure out what happened to something when that line goes down to the tune of $50,000 an hour or whatever that line happens to be worth. They could care less. It's important to me, so that's where I need people that provide these devices to be a little bit more capable from a forensics diagnostics perspective versus just when I'm on, I've got something, when I don't, I don't.
Okay, thank you very much. Can we... Sure.
And when you're developing the standards, make sure you fail it so that I can keep talking to all my other devices instead of bringing the entire network down.
Thank you very much.